and now multiplying in scientific notation. More specifically, we're going to see problems like this, where we've got one number in scientific notation times another. These two look all the same, just the 3 and the 7, but something interesting is going to happen when we change this to a 7. We're going to learn what happens and what to do about it. Okay, here we go. Let's dive in. Now, first thing, let's just dive in and think about, I just want to point out how different these might be written. So, again, the whole point is this is multiplication, right? We're applying. So, times, sometimes there's no times, it's just a parenthesis times a parenthesis. Those all mean the same thing. Okay, now let's just focus on this last format. Usually the easiest because there's less to write, fewer symbols. Now what this is you've got to remember, with multiplication we can change the order of the factors. We call that the commutative property, right? Commute means move, like you're commuting to work. So we're going to move things around, and in particular what I want to do is I want to group the coefficients, right? Sometimes we might call this the first factor, but the 2 and the 3 we want to group, and then the 10 to the 8th and the 10 to the 9th. Now when we do that, then we're going to see that things simplify in a nice way. So I have 2 times 3, and then whatever that is going to be times 10 to the 8th times 10 to the 9th. Okay? Again, you can see I'm using times in many different ways, right? Sometimes we use it as dot, sometimes as an x. Anyway, so let's do this. Let's simplify this first statement. Well, 2 times 3, whew, got to think hard on that one. I think that's 6. This comes down, that little x for the multiplication. Now remember, 10 to the 8th times 10 to the 9th, when we have the same base, we add the exponents. So this is 10 to the 8 plus 9. Okay? And again, let's just emphasize what happened here, right? 2 times 3, right? We multiply the factor in front. Sometimes we call that the decimal. We might call it coefficient, different terms, but to use there. But basically, those just get multiplied pretty normally, and then since these are powers, we add the exponents, right? Okay. Now that's pretty good. We're almost done. Let's just put it all together, and this becomes 6 times 10 to the 17th. And remember, when we use scientific notation, we usually use an x between the first factor and the power of 10. Okay, so that's how that works. Now, I know this isn't about adding in scientific notation, but I do want to just really quickly do one because, as a comparison, because it acts very differently. Okay, again, what this particular problem is, I am adding this time, not multiplying. And again, I just want to do a quick review so we can remind ourselves what happens when we add, so we see the differences. All right, so now remember, when we add, it's actually easier to work vertically. When we multiply, we're actually working horizontally when we have scientific notation. So I'm going to rewrite these, but I'm going to write them vertically. So I'm going to have 2 times 10 to the 8th, and again, I have to line up the decimals here, right? 3 times 10 to the 9th. Okay, now you might be tempted just to start adding, but the problem is these exponents aren't the same. Look, I've got an 8 and I got a 9. Those are not the same thing. That's like adding apples and oranges. So I need them both to be the same. Now, there's different ways you can do it, but for this one, let's just change this 8 to a 9. Okay, now I'd like it to be the same. Now, if this was a 9, now I can add them, right? Because I've got 2, and this is billions, by the way. This would be like 3 billions. Now, but to do that, I have to change this 2, right? So let's think what happened. This went from an 8 to a 9. It got bigger, right? So because this went bigger, I've got to do the opposite and make this smaller, right? You always got to counterbalance them. And recall that there's this invisible decimal point here, right? So I got to move it over. I'm just moving over 1, right? So it becomes 0.2. Now that's kind of messy. I don't like it like that. So let's clean it up a little bit. And here's how we're going to do that. We're going to bring it over to the side. cleaning that up. Okay? Okay, so I've got 0.2 times 10 to the 9th and 3. Now, if you want, you can go ahead and write out that that's 3.0, just if you want to make it really obvious, times 10 to the 9th. Okay? All right, now I need to pull down a little bit so I have some room here, and we're just going to add them up. Again, really important, I've got the decimal points lined up. So when I do that, I end up with 3.2 times 10 to the 9th. That would be my answer, 3.2 times 10 to the 9th. Again, super critical that the exponents were the same. But let's look at this and just really quickly compare how different that was, right? When I was multiplying, right, I didn't care that these exponents were different, right? It just doesn't matter. But here, when I'm adding, it's really critical that they be the same, right? Because again, this is like saying, this is not, they've got to be the same thing, right? 0.2 billion, 3 billion. Those can add up and you get, well, 0.2 plus 3, I should say 3.2 billion. It makes sense. Okay, just wanted to make sure that's super clear so we don't get confused going forward. All right, so let's now take it to the next step. Something's going to happen on this problem that's going to make it slightly harder than what we did a second ago. Okay, and let's see. Okay, so, right, and I'm just going to tell you right off the bat, you might need to fix the format, and we'll see what that means. Okay, so I've got 2 times 10 to the 8th, 7. Okay, just like I did a second ago, right, I'm going to group my first factor, right, 2 times 7 times, now this is, I'm not going to write it quite so much, I'm just going to write it out, right? This is going to be 10 to the 8 plus 9, okay? 2 times 7, well, that's just 14 times 10 to the 17th, right? Well, hey, I'm good, right? Well, remember, there's a problem. In scientific notation, I can't have values here in front that are 10 or bigger. In other words, there should only be one digit in front of the decimal point. Well, that's not the case, is it? I've got 2. So I'm going to have to move this guy. I don't like the decimal point there. I got to move him over. Okay? Well, hey, if I move him over, that would look good, but I've got to now fix the fact that I changed it, right? So now let's think. 14 got smaller. If 14 got smaller to 1.4, then this has to counterbalance. And 17 has to get bigger. Turns into an 18. Okay? All right, and then let's just rewrite it nice and clean, right? 1.4 times 10 to the 18, okay? All right, so let's now review what just happened here, okay? So, got my little handy-dandy set of rules here. So this is basically what we're going to be doing today. When we multiply in scientific notation, there's basically 3 things we need to think about. We're going to multiply the coefficients. Again, that's the first factor, if you want to think about it that way. You're going to add the exponents. I don't care if they're different, right? 8 and 9, they're different. No big deal. And then at the end, you might need to fix the format. Sometimes you do, sometimes you don't. More often than not, you're probably going to have to fix the format. Right, so like we did here. Okay, so those 3 steps, you might want to jot that down. Multiply the coefficients, add the exponents, fix the format. Okay. All right, let's do one last example where it's a little messier, but now that we're good at this, we're going to be awesome. Okay, and in particular, careful when you've got decimals. Okay, all right, so let's zoom in on this guy. And what we've got here, right, 2.34 times 10 to the 7th, 5.6 times 10 to the 8th. Okay, all right, so in particular, I'm going to group my coefficient, my first factor, and I end with 2.34 times 5.6. And whenever you have decimals, notice I'm really trying to be careful that you can tell the difference between a decimal and the multiplication. You might consider doing this as an X just to make sure there's no confusion there. But whatever you do, just be careful. And then this is 10 to the 7 plus 8. 7 plus 8. Okay, now if I multiply that out, 2.34 times 5.6 is 13.104 rather, times 10 to the 15th. Just to be clear, I didn't do that one in my head. Okay, so now we're almost there again. Not quite in the right format, is it, right? There should only be one digit to the left of that decimal point. So I got to move the decimal point over. Okay, got to move it over. But by moving it over, that made this guy smaller. This guy's getting smaller. This exponent has to get bigger to counterbalance it, right? So this 15 becomes a 16. And then finally, I've got 1.3104 times 10 to the 16. All right? And again, let's zoom it out. Remind ourselves of what we just did here. Okay? Right? The key steps. We multiplied the coefficients, right? 2.34 times 5.6, right? We added the exponents, right? I added 7 and I added 8, which gave me 15. And then I fixed the format in the end. This would be a really good thing to jot in your notebook. Well, that's it for today. Next time, we're going to talk about dividing in scientific notation. Can't wait to talk to you about that.